Hi folks, we're going to take a look at page 389, number 11. So here they give us three forces with magnitudes 3, 4, and 5 newtons that are acting on an object, and this object is in equilibrium. And then they want us to find the angle between the smallest and largest forces. So first thing to recall is to remember what it means to be in equilibrium. So that means that all the forces have to add up to 0. And of course, that means that if I were to add these three forces, um, tip to tail, they should form a closed triangle because I should end wherever I started. Okay. Now notice they don't give me any information about the directions, even relative to each other, but I should be able to draw a sketch because I know that they're in equilibrium. So I know that whatever I draw, they need to form a closed triangle. All right, so let's start with drawing the largest one. So let's say I let this be my 5 Newton force. Okay, and then I'll try to draw a second one, which is maybe not quite as long. So there's my 4 Newton force. So I'll give that 5, 4, and then the smallest one here, okay, is my 3 Newton force. Okay. So I'm not going to worry. I definitely don't assume that this is going to be, a right angle triangle here. Don't make any assumptions, okay? Even though, we might figure that it very likely is. But what we want to determine is the angle between the smallest force and the largest force. And I hope you're seeing that the angle that we won't be using will be this one here because they're not placed tail to tail. So the way in which we give the angle between two vectors is it must be tail to tail. All right. So what I'm going to do in the interim is I'm just going to move this vector down, this vector 3 down, so that it's tail to tail with vector 5. And hopefully that'll help me figure out what it is that I need to determine. So I'm looking for this vector. Let's call it theta. That's what I'm looking for. Okay. But of course, this vector, this angle, theta, is not inside the triangle. And of course, I want to work inside the triangle. But I notice here that, again, I'm just moving this down. This whole thing creates one straight line. So the angle here inside the triangle, which I'll call phi, is going to be supplementary to angle theta. So here we have theta plus phi is equal to 180. And so if I find this angle here, I'm able to find angle theta. All right, so again, very important to recognize that even though I was able to draw this diagram, it's the angle that I'm looking for inside the triangle is not going to be my actual final answer. I need to find the one where they're placed tail to tail. All right, so let's do that here. So I've got the 3 side lengths, so I'm able to use cosine law. Now, when you're using cosine law for finding angles, maybe you remember the shorthand just to go to the angle right away, but just in case you don't, okay, just write out the cosine law and then solve for the angle you're looking for. So here, I'd have on one side the 4 squared, the opposite side, so 4 squared equals the sum of the squares of the other two sides. Okay, minus 2 times 3 times 5 times cosine of the angle that I'm looking for. And now I can just solve for this angle phi. Okay, and again, if you need to do this in more than one step, that's perfectly fine. But of course, I'm going to bring these two expressions, I'm going to subtract them to the other side. So 4 squared minus 3 squared minus 5 squared. Then I'm going to divide by the factor in front of cos phi, which is negative 2 times 3 times 5. And then, of course, I'm going to take, I should have left a little bit of room. I'm going to take cos inverse of all that to find my angle. All right. So here I'm going to find an approximation. All right. So let's do this here. So you can do this in 2 steps. I'm going to see if I can manage this in 1 step. So cos inverse, I'm going to open up a bracket for my numerator. So 4 squared minus 3 squared minus 5 squared, close my bracket, divided by, open my bracket for my denominator, negative 2 times 3 times 5. You see, I'm just letting the calculator do all the work for me. Okay, so this is 53.1 degrees, but of course this is not the angle I'm interested in. I'm interested in the supplementary angle. So theta is going to be 180 minus 53.1, and that's approximately equal to, so I'll just subtract 180 here. So it looks like that's 126.9. And there's my angle. All right, so step number one was to realize that because this object was in equilibrium, the three forces added up tip to tail needed to form a triangle. Number two is recognize this angle between the largest and the smallest vector is not the one you're looking for as a final answer, that you have to move your smaller vector. I guess you could have done the same thing with the larger vector, move it up there, okay, to get them tail to tail, and then realize that those two angles were just supplementary to each other. Okay, that's it for this one.